Hello viewers, welcome back to my channel. Today we shall be looking at the following questions and then we try to see how we can solve them. The first one here says, a ball is released from a height of 80 meters above the ground. Given that the acceleration due to gravity is 9.8 meters per second square. So there is supposed to be square here. Okay. What is the maximum velocity of the ball before it hits the ground? What is the maximum velocity of the ball before it hits the ground? For you to be able to solve this very problem, you should be able to memorize the equations of motion. So from the question, we have been given the height to be 80 meters, then acceleration due to gravity to be 9.8 meters per second square, and we are to find the velocity. Looking at the equations of motions that we have written here, let me take this one as equation 1. This is equation 2. And this one is equation 3. Okay, so this is velocity v equals to initial velocity u plus or minus at. In this case, the a here becomes g. That's acceleration due to gravity. Okay, and the s here becomes height. So change this to height. All right. Now let's look at it. Here we have h. The first equation does not have h. It has g and v. So it is not fit for us to use. Look at the second equation. That one has velocity and we have v here. Initial velocity of the motion is 0 because the object is about to fall to the ground. So initial velocity would be 0. Let me include that u equals to 0. Okay, so we have g and we also have the height. So equation 2 is complete. Then equation 3 has height. And then this square equals to u square plus 2as. This will be 2as. Or 2gh. Okay. So equation 3 has time. And we do not have time here. So this is the best equation for us to use in solving that very equation. So we compare the quantities they give to us and see the one that aligns with the equation is the one we would use. Okay, so we are now going to substitute the values we have here into equation 2. Let me erase this one. Since the body is falling to the ground, initial velocity is 0. So even if we put u in this equation, it will reduce to, it's just the same as not putting anything. And another thing I want to say is this. The plus or minus here represents two things. If the object is projected high into the air, we use minus because it is moving against gravity. But if the object is allowed to come down, just like this one, we are going to use plus because it is moving in the direction of gravity. So here, I'm going to change this to plus. If I substitute u equals to 0, this expression reduces to what we have here. So we now have that v squared equals to 2gh. Since we are looking for v, we make v the subject here. So when we make v the subject, our final expression would be v squared equals to root 2gh. So from here, making v the subject, we will have v equals to root 2gh, which is the same thing as 2 times, what's g here? 9.8 times h, 80. Okay, so when we simplify this expression, we will have, so we would have square root of 1568, and if we find the square root of 1568, this will give us 39.60 meters per second. Okay, so let's go to the next question. This one says, Figure 1 shows the units for measuring length according to sizes. What is the name of the omitted unit? We look at this figure here. It comes with some units. Okay, so this one is 10 to the power minus 18 atto, 10 to the power minus 15 femto. This is 10 to the power minus 12. This one is omitted. 10 to the power minus 12 is pico. We have here 10 to the power minus 9, which is nano. This one is 10 to the power minus 6, micro. 10 to the power minus 3, milli. 10 to the power 0 is meter. 10 to the power 3, kilo. 10 to the power 6, mega. So we have to know all these things, and then we memorize them into our memory. Giga, 10 to the power 9, tera, 10 to the power 12, and all of that. But the missing name here is 10 to the power minus 12, and the name is pico. Okay, so let's move quickly to another question. This one says, determine the dimension of pressure and force. We have treated dimensions before, so I may not really break it down the way I did in our previous class. But I'm going to start with force and then we go to pressure, because we can still use what we have here to get that of pressure. So we have force here. The dimension of force here is mL t to the power minus 2. We use the expression here, the mathematical expression, to derive the dimensions. Recall that force F equals to product of mass times acceleration, or we can use acceleration due to gravity. So this is mass times acceleration. Now, what is the unit of mass? Kilogram. What is the unit of acceleration due to gravity? Meters per second square. Let me bring it down so we see it clearly. Our force unit is kilogram, and that of this one, acceleration, is meters per second square. We are going to change this to dimensions. So kilogram stands for mass, so we are going to replace m. Then this is length, small m, length, L, all over S squared, this time T squared, which could be written as m L T to the power minus, because this one is inverted. So this is dimension of force. Then pressure, P, is force per unit area. Force per unit area. Force over area. All right, so the unit of force is what we have up here. Kilogram meters per second square, all over the unit of area, which is meter square. If we simplify this mathematically, I put over 1 here. I can't leave it this way. Remember, in mathematics, if you have A over B divided by C over D, this can as well be written as A over B. Then you turn the denominator. You turn the denominator, then this division line here will change to multiplication. So this will give you times D all over C. We are going to apply this here. If we apply this method in this unit, we are going to have kilogram meters per second kilogram meters per second square times 1 all over m square. So what is common? We have m here, we have m. This one is double m. M square means 1 over m times 1 over m. So this one strikes this one, remaining one of this. So this will now be kg over m s to power 2 in dimensions could be written as m for mass, then this is length, small m. Here stands for length, so this would be m l d to the power minus 2. All right. I omitted minus, this is supposed to be m l to power minus 1. Okay, so this is the dimensions for pressure. M L to power minus 1, T to power minus 2. Let us go to the next question. The next question says, write down the 7 basic quantities. Write down the 7 basic quantities. In a question like that, the examiner expects us to mention the fundamental quantities, which we have here. Length, time, mass, electric current, temperature, amount of substance. All right. Let's go to the next question. Okay, the question says, given that D equals to 20 millimeter in figure 2. So here is figure 2. And this D here is diameter and of this shape, the cylinder, the internal diameter. Given that D equals to 20 millimeter, which is a small value in figure 2, mention an instrument that is most suited for measuring D. Mention an instrument that is most suited for measuring D. There are instruments we can use to measure internal and external diameter of small shapes. The vernier caliper has those qualities. So this is the vernier caliper. Could be used to measure external diameter of a cylinder here, while the internal diameter of this container could also be measured. So the vernier caliper is most suitable we cannot use the micrometer screw gauge in that measurement. Let me not delay you. Let me move to the next question. This other question says, given that the pointer of a stopwatch moves from point I to point II in figure 3, determine its reading. So we have figure 3 up here. So this is the figure. So the pointer initially pointed at this and then later moved to II. This is a stopwatch and it is usually graduated in seconds. So we'll take this point here as 5 seconds, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So the first pointer was at 55. So we take this as 55 point. Then it's now pointing at 5, 10, 15, 20. This was 55. This one is 20. So we'll take 55.20 as the answer. Let's go to the next question. This one says, what type of error do you avoid when you repeat your experiment? What type of error do you avoid when you repeat your experiment? The type of error you avoid when you repeat your experiment is the random error. So the random error is avoided through repetitions and averaging. You avoid the random error when you are doing an experiment through repetition and averaging. That's how far I can go. I will just glance through a few of these. This one says, an image that cannot be formed on a screen is called, it's a virtual image. An image that cannot be formed on a screen is virtual. A real image is one that is formed on a screen. This one says, a reaction that takes place at constant volume is called isocuric. Option C here. Let this green so you can see it. Isocuric. Let me read through this. What are the names and readings of these instruments? What are the names and readings of this instrument? I'm seeing a micrometer, screw gauge, and a vernier caliper. So I think I would handle this in our next class. Have a wonderful day.